Hi there and welcome back to Triplicate, and moving on with getting the boat speedometer peripherals working. So we got all the top board ones working, that's the top board, and then started on the bottom board with this GPS module which slots in under here. And as you will have probably seen from the short I did, the video short, I did the electrical short from this, which is all up at 15 volts, to one of the Nucleo pins. Oh dear, dead. So anyway, I have a new one. I actually have a new one, but this is the one I pinched off the Heresy. And there's the board, and had further problems, just would not work. Just could not get it to read from the input, and buzzed it all through, and the baud rates were right and everything was right. So lots of head scratching later. So eventually I just generated a test project for this Nucleo board, and this is what happens, this is what you get with no pins set up to do what you want to do. And you can see UART TX and UART RX now, they are used by the programming interface on the Nucleo, and though that UART was the one I was supposedly trying to use for the GPS, and it isn't actually connected on the Nucleo to the processor, so that's why that didn't work. So that's PA2 and PA3 here are what I've assigned to the GPS, which I can't use, but I've assigned XCOMS RX and XCOMS TX up here, and those I have not wired in on my bottom board. So what I was thinking of doing with those, I don't know, but now they are going to be the GPS comms. Okay, and I got very lucky because the UART input I cannot use apparently is PA3, and the one I'm moving it to is PA10, and they are two away. So because PA3 on that connector is not connected to anything, actually connected to anything on the board, I can just bridge between PA3 and PA10 and we should be up and running. Just change the UART number to 1 instead of 2 and we're good to go. So there you go, we have this convenient Arduino form factor connector with holes in it. So just one bent bit of tin copper wire across there, and that's it. That's the only modification I need to make. So that was thankfully pretty easy. Okay, so it is now running, and that little green light is GPS data going between here and the PC. And if I tip this on edge, you can see, hopefully, the little red light on the GPS board telling us the GPS is taking readings nicely. Okay, so if we fire the PC monitor program up here it comes, there we go, and we are getting lots of nice NMEA type data. Okay, so we actually need, really we just need position and time out of all that jolly lot. So let's see if we can get that. Okay, I've just tidied up the software a bit. So it looks a bit nicer and we can actually see a proper position reading. So let's run this. There we go, and it defaults to position and it gives us the time in UTC and the latitude and the longitude, which are fiddle, so you can't just look at where my house is. Just in case you were wondering. And we've also got a raw button here. So those are all the messages that it's coming out with, all sorts of wonderful and wacky data. So I am happy that we have what we need from the GPS, pretty much. So let's move on to the SD card. Okay, moving on to the SD card, and I have made a kind of a bit of a boo-boo in that I assumed this is the little socket for it, and I assumed the connections at this end and the card would go in from that end, but no, the card goes in the same end as the connections, i.e. this end, and as you can see there are some components underneath it. If it doesn't want to go in too easy. Come on. Oh, there you go, that's in. But you can see that's a little capacitor, decoupling capacitor underneath the bottom, so it's just tipped up slightly, so hopefully it'll work. It may eventually damage the card, break the card from being the bend on it, or it may pull the socket off the board, but for now we're going with it as it is. Okay, so couldn't remember how to get the SD card code to work, and also had, you'll find this hard to believe, dry joint problems on the SD card holder. One of those soldered to the board, and on the pins to the Nucleo connectors. What a surprise! So I ended up with this bird's nest hanging off the top of the Nucleo, just to make sure I could actually talk to the card. And I could, and I cured all the dry joints, so we can get rid of all this stuff. Ta-da! That's better. That's better. Okay, so then I had to go back and watch part 5 of this series of videos to see exactly what I was supposed to do, and because I went round and round the houses very seriously and did lots of things that didn't work, it wasn't, I felt, totally clear as to what I did in the end that did work. So I will go through it again. So here we go. First up, in the code, in the FATFS folder, target folder therein, you add disk.io.spi.c and disk.io.spi.h, and there's a link in the description as to where you can download those two files. And you then need to clean the project and rebuild, and they will then appear nicely in the target and all compile up. And then you need to go in to disk.io.c and do some modifications. So if we look in, okay, user initialized, and we then have to, instead of doing what it normally does, which is say I can't do anything, we have to call user SPI initialize, Similarly, the status function we call user SPI status. The read function we call user SPI read. The write function we call user SPI write. And the IO control function we call user SPI IOCTL. So you just have to put those lines into that file. And then you have to, in main.h, define SD-SPI handle as HSPI 2 in my case, because we're using SPI 2, which is what the HAL calls the SPI. If you were using SPI 1, that would be HSPI 1. And lastly, make sure that the port pin you are using as the chip select for the SPI, you have labelled SD_CS, because the SPI driver expects to have a pin so labelled to use as the chip select. So having done all that, it should work. Okay, so I have implemented the same functionality I had on the original test when we were just trying to get the SD card working. I've also got that SD card plugged in, rather the bigger one I hope to use eventually. So first up we'll try loopback. Yep, that's working. So let's see what the SD status tells us. FR OK, brilliant, it's mounted OK. So let's list what we have on the SD card. There you go. And if we take that file name and do a read, there you go. It reads the contents of that file. So the only thing we lack, I think, is the ability to write to the card. So shall we have a look and see if we can implement that now? Okay, here we are. As you can see, we have added a write button and a pen button and a delete button. So we do the status because that mounts it as well. We do a list, and yeah, I've added a 1x1 file. So we will add a test file.txt. No, txt. So now we will write that. So this creates the file, and that's now created the file. So if we read the file, yep, it's got one line in it, which is the current GPS position. That's all it writes when I ask it to write. So now if I write again, and read again, look at the date here, look at the date, the time here should I say. Okay, so that's reopened the file and rewritten another line of text in it. So if we append to that and then read, we've now got the two lines, append, and again reline, etc. So I am liking that. And last but not least, if we list, if we take our wombat1.txt file and hit delete, it's like that. So if we now list, there you go, the wombat1 file is gone. So happy. I think the SD card is good for now. I mean, we may well have to tinker with it once we start actually trying to write serious files. But for now, we are going to move on to the Bluetooth. Oh. Okay, so here it is. Here's the Bluetooth module plugged in under there. and kind of hanging off the side of the board rather precariously, and it's upside down, so if you look at it that way you can see the antenna trace. So shall we see if we can get it working? Okay, so this is the code from my original Bluetooth test program, the one where I connected the Bluetooth module directly to the FTDI and thence to the PC. So I have taken this and put it in the new code, and some of the other code from there I have put into the code in the STM32, and that is currently running in the STM32. So let's fire this up. Okay, so here it is. We'll do a sanity check. We've got all the commands I hard coded in for the other one. So if we do AT, it says 8, it sends AT and it gets back okay, I like it. And reset basically does the same thing. Version doesn't work. Name works. BT05. Pin. That's whatever the pin is. Oh, that's for pairing it up. 1, 2, 3, 4, 5, 6. And help. Prints a bunch of commands out. Excellent. Okay, and it seems if you reset it, it takes a bit of time to sort itself out. So, right, version normally it works v6.3. Sure you wanted to know that. Okay, so let's get on now and see if we can actually use it to transmit data somewhere. Okay, so Bluetooth. Well, I got all the AT command stuff to work, so you can change the baud rate and what have you and do but I could not get it to pair properly with the PC. It will pair with my Android tablet, no problem, and then I can transfer data backwards and forwards to a little terminal app on the tablet. Interestingly, it won't pair unless the terminal app is running, so don't know why that is. So I've tried pairing it with the PC, tried thinking of everything I possibly can think of, been round, watched videos, been on forums, yada yada. Won't connect to my PC. Tried Angela's Windows 11 PC, won't connect to that either, does exactly the same. Okay, so then I decided to get into to try and get into Bluetooth a bit and see if I could actually, drive it from code. So here we have a Bluetooth object that C++ gives you, C++ Builder gives you. And to that I've added a discover button, and if I go into here you simply say discover devices, and 5,000 is the timeout, how long it's going to wait, try and discover some for, and then it sends you a message back when it's discovered it, and we can get into there, discover devices, count. Great. Okay, if I fire that up with our little Bluetooth module powered down, okay, discover, start discover devices, 5 seconds, end discover devices, not found any. Okay, fair enough. So now we will, and I'm going to do this off camera, plug our little Bluetooth module in again. If I get the plug in the socket. There we go. And shall we run this again? Start discover devices. 1. So it has discovered our device. At this point I was over the moon. I thought this is going to be easy. All we need now is some nice functions where I can say what is device 0. Oh, that's the one I want, and here's the pin for it, and can I read to it and write to it. But no, once you get that far you are down in the depths of Bluetooth stuff, which, to be quite frank, I don't want to know about. I've got better things to do with my time than learn exactly how Bluetooth all works. What I want is something like the FTDI chip, where it does all the USB for you and gives you it gives you a UART connection at one end and a COM driver at the other end. So where now? Okay, Bluetooth and other devices. So this is what's happening. I'll just show you this again. It was part 4 was Bluetooth. There it is, BT05. Connecting, wants a pin, 1, 2, 3, 4, 5, 6. Connect. Okay, and that'll just sit there doing nothing and then tell you to come back later. So it was part 4, if you want to look back again, that I was initially trying to get the Bluetooth working. I thought, oh, I've got it working with the Android, so surely I can get it working with the Windows with a bit of effort. Nope. If we get to the end of it, yada yada yada. Oh yeah, try connecting your device again. Yeah, you can try forever and it doesn't work. But I have, while going round and round the internet, discovered you can go in more Bluetooth options. COM ports, and you can set a COM port up, associate a COM port with your Bluetooth module. And I've seen people doing this with Arduino based systems on videos, and then it is what I want. It's just a COM port at the PC end and don't have to worry about Bluetooth, but you have to be able to connect to it first, or there's no point having that. So okay, what to do? Well, the original HM10 module, of which the one I'm using is basically a knockoff from unknown source. Well, the original one was made by DSD Tech, and also in my travels around the internet and Bluetooth modules, I saw 2 or 3 videos of people using HC05 modules successfully. So I am going to buy a genuine DSD Tech HC05 and a genuine DSD Tech HM10 module, and through gritted teeth I'm going to buy them from Amazon, or Angela's going to buy them on her Prime account, and then we shall reconvene. And if that doesn't work, well, I think it's probably drilling a hole in the side of the case and sticking a USB plug in. Okay, so here we have the genuine HM10 powered by DS Tech, and it even says HM10 on it. So shall we give that a go? Plug it into the PC, and there we go. What's the PC saying? Oh, there it is. So let's go here, connecting, and just seems to have done, and there it is, connected and paired. Okay. I don't remember how to... Is it more Bluetooth? More Bluetooth options. COM ports. and outgoing. We will not initiate the connection. Nothing there. Browse. Nothing there. So that still doesn't work. Okay, well, we'll try also with Android. So I can't remember how to do this. Devices. There we go. Connected. So okay, so here we have our test app. COM port open 5. So let us bring the terminal back in and type into here. Oh no. Into there, send, and there it is. So it works with Android, with Windows, no. Now I could probably get away with typing commands instead of having buttons that send a command, actually typing the commands in here, but it's really faffy. Don't want to do that. And I could write an app for Android, but right now I don't want to get into programming Android. So, okay, so here we have an HC05, which as far as I'm aware is obsolete from as far as DS Tech are concerned. They don't, so you can't buy them off their Amazon website. And I'm from Germany with some German books. Sadly my German is not up to reading them. So we will try this. Connections, well it's a ZS040 board again. So it should connect the same. RX, TX, ground, VCC, and then the outside 2 not used. Okay, let's then power it up and see what happens. Okay, plugged in and ready to go. Let's power it up. Okay, fast flashing LED. Right. Yeah, shall we see if we can find it in the land of PC Bluetooth. Come on. There we go. Unknown device. HC05. I don't know the pin. We try 1, 2, 3, 4. Your device is ready to go. Done. Okay, so more Bluetooth options. To see if COM ports will now. Oh, there we go. 7 is outgoing and 8 is incoming. Okay, well we're now going to try that. We are going to, I guess, have to write some code to read and write to those ports. Okay, so it seemed a bit weird using one COM port for in and one COM port for out, and I tried it and guess what, didn't work. So I did some more digging on the internet and found somebody, instead of going into settings, devices, Bluetooth, more Bluetooth options, COM ports and getting 2 COM ports, they had gone into control panel. There we go. Let's just put that at the bottom so it's not causing any confusions. Devices and printers. HCO5, which is what we're looking at, and properties. Hardware. Shared serial over COM port link, COM7. So why, oh Microsoft? If you go in one way you get 2 COM ports, if you go in another way you get 1 COM port. But the video seemed to show that was the COM port they were using, so that is the COM port we are going to use. Okay, so we fire the COM port up to the FTDI and that's open. And we fire the COM port up to the Bluetooth. Both ports are open. I'm still opening both ports, but I'm only actually using port 7. And let us send a message from the FTDI, which will eventually be the boat Speedo, via the Bluetooth to the PC, and that works. Okay, we will send a message from Bluetooth, so Bluetooth from the PC to the Bluetooth module, and then it comes back in through the FTDI into this program. So send, and it works. Hey, God. So there you go. Actually finally have Bluetooth talking to the PC after however many days and 2 nervous breakdowns. Okay, so onward and upward. So the next step is to take this off of here. Come on, like that. And plug it in there, and I kind of expect the code in here already to work because it's the same board as the original one, and this was talking to the Bluetooth. It's just the Bluetooth wasn't talking to the PC. And then I also need to come up with some code at the other end. I guess some just kind of, well, probably just when it turns on, if it receives a command over Bluetooth, it goes into Bluetooth mode. If it receives a command over the debug interface, it goes into USB mode, but we shall see. However, at this point I have totally run out of time to do any further work on this video, and this video has got to be a bit long anyway, so that is going to have to be next time. But at least now we are in a position to start writing the proper software. But next time I might instead go over to hardware and build these light bars, or a first hit at these light bars, and see how that goes. And get a load of junk out of there. See if we can actually mount this in here. So that'll be exciting, won't it? So until then, I am going to take my leave, so it is goodbye from Triplicate. Goodbye.